Hello students, welcome to Sort of Sales classes. In this video, I will be solving the following question from ISS 2017 paper 3. Now here we have to define the seasonal variation in time series, and then we have to explain the link relative method of computing the seasonal indices. Now first, what is seasonal variation? Now seasonal variation, it is the variable element in time series analysis of forecasting, and it refers to the phenomenons that it refers to the phenomenon where the production and the plan of product. So the production and the plan of product, it change on a certain seasonal trend, For example, let us consider ice cream. Now, ice cream, we know that its consumption increases in summer. So this change that is happening, this is called seasonal variation, and because of this increasing consumption during summer, so there has to be a changing in the production and planning of this product, and this change in the production and planning of this product is called seasonal variation. Now there are different methods in computing the seasonal indices. One of the method is link relatives. Now first, what is link relative? Link relative, short form for LR, this is equals to the data of current season. So this is equals to the data of current season, let it denoted by M1. So it is the data, LR current, it is the data of current season, so let us denote it with MC, data of current season, divided by the data of previous season, that is MP, which is the data of the preceding season or preceding period. So it is the data of current period, which can be month or quarter, divided by the data of previous period into 100. That is, the link relative can be expressed in as percentage. It is expressed in percentage, the ratio between the data of current period to that of the previous period. So LR current is given by this. So what are the steps required to compute the seasonal indices? So steps are: number 1, that we have to compute these link relatives, that is, we have to compute LR for each period. So we obtain the LR for each period. Now, so the first step is to compute the LR, that is link relative of each period. Next step is to arrange these linked relatives and obtain the seasonal average of linked relatives. So obtain the seasonal average of linked relatives. Now this can be done either by mean or median. So we have to obtain the seasonal average of the linked relatives, that is the linked relatives of all the season or the period from the season wise from the different years. That is, suppose we have 4 quarters, quarter 1, 2, 3, 4, and it is been done for 4 years, say year 1, 2, 3, 4. Then first we obtain the LR for each of these. So we obtain the LR for each of these. Now once we obtain this LR, we will obtain the seasonal average, that is average of these four, like this. So we will obtain the seasonal average of LR. So this is the step number 2. Next is that we will convert these average link relatives to chain relatives, in short called CR, where this chain relative of current period, it is equals to a link relative of current period into chain relative of previous period divided by 100, where the link relative, the chain relative of first season or first period, it is considered equals to 100. So from this process, from this calculation or this formula, we compute the chain relatives of all the periods except the first one. Then the next step is that we would find the revised chain relative of first period, which is equals to CR revised of first period. It is equals to this average link relative of first period. So the average, this is also the average link relative. So the average link relative of the first period into the chain relative of last period. So into chain relative of last period divided by 100. So this is the revised chain relative of the first period. Now what we would do is that we would determine the constant correction factor. So we would determine this correction factor D. So it is step number 5 that we would determine the correction factor D, which is equals to this revised chain relative for the first period minus the initial chain relative for the first period, which is equals to 100, thus divided by n, where n is the number of periods in 1 year. That is, suppose in case of quarterly, n is equals to 4. In case of monthly, the n would be equals to 12, and so on. Now next is we do the deduction of this correction factor D after being multiplied by 1, 2, 3 and so on from chain relatives of second, third, fourth, so on, respectively, periods. So what we do is we reduce this d after being multiplied by 1, 2, 3, so on, respectively, from the chain relatives of second, third, fourth, so on seasons or so on periods. So by this we will find the preliminary indices. So we will find the preliminary indices of the seasonal variation, and the last step is that we have to express these preliminary indices. So let us denote it by pi. So we will express this pi as percentage of their average to get the required seasonal average to get the required seasonal indices. So these are the steps with which we compute the seasonal indices with the help of link relatives.